then promoted to a senior professor in 2016. To his credit, Professor Rohana Chandrajith has several awards such as Humboldt Fellow, then the President's Awards for Scientific Publication on several occasions, and several other awards, including the CVCD Excellence Award for Most Outstanding Senior Researcher, and the prestigious Ananda Kumaraswamy Medal awarded by the Geological Society of Sri Lanka for his contribution to geology, the field of geology in Sri Lanka. So he's the first to talk today, and he's also a fellow of the National Academy of Science since 2013. So it's my pleasure to welcome Professor Rohana Chandrajith. Professor Chandrajith, over to you first, please.
Okay. A few years ago, I was doing fieldworks in a rural village in Sri Lanka, dry zone of Sri Lanka. And I met a boy of about 10 years old who is living in the village his entire life. As an innocent child, was smiling with me. These slides are not working. Yeah, he was smiling with me, and this is what I have seen from his face. Not only him actually, but many others also had some health implication in this region, like the person who is in this slide. The reason for this complication are the excessive intake of fluoride through drinking water. That is actually not industrially contaminated, but released from soil and rock, as they rely entirely on groundwater for drinking and cooking. Okay, ladies and gentlemen, I wish you all a nice, very nice evening. And I'm Chandrajith from Department of Geology, University of Peradeniya. Thank you for the warm introduction given, and it is great honor for me to speak on this occasion of Earth Day. I express my sincere thanks to organizing committee for inviting me to this event. Okay, as you noticed a few moments ago, I showed you how the geological environment, or in other words, the Earth, affect the health of living organisms. Over maybe next 20 minutes, I would like to give you an introduction to the emerging field of medical geology and its connection to concept of One Health. Since the environmental factors influence the health of humans as well as animals, we consider everything together as One Health. This is the lineup. I'll just give you an introduction to One Health and what is medical geology, then some basic concept and background of medical geology, as well as I'll discuss some few issues related with water quality and health, and also some few other interesting issues related with medical geology. Okay, first we'll just look on One Health. Actually, One Health is a broad, it is recognized as a broad discipline. Actually, it is including health of human, health of animal, as well as the environment. The linkage between human health, animal health, and the environment is given by the One Health concept. Actually, human and animal health are interdependent. At the same time, both depend on the environment, where earth science or earth scientists play a major contribution in this aspect. Just look at a small cartoon, actually. Let's consider application of fertilizer. As you know, actually, most of the fertilizers are having a geological origin. For example, we are using phosphate fertilizer or potash fertilizer, what we call muriate of potash. Basically, both are having a purely geological origin. Now, we apply fertilizer for crops or pasture. Maybe fertilizer might be contaminated. For example, some fertilizer, particularly phosphate fertilizer, is contaminated with cadmium. then what happened? Cadmium can be added into soil as well as in water, and also it can be accumulated in plant. Plant can uptake cadmium, and then it can be transferred into human either directly through drinking water or maybe through food chain. Sometimes it may be through animals, maybe particularly livestock feeding on grasses that may contaminated with cadmium, and that can be transmitted to human through milk and meat. Basically, we can observe some interaction between human and environment, as well as human and animal, as well as environment and the animal. Okay, this is again showing a cartoon that showing the interaction and influence of natural environmental factors on the health of population. Okay, now the interaction and also influence of natural environmental factors on the health of population is known for centuries. In 5th century BC, Hippocrates, considered as a father of the modern medicine, said, if you want to learn about the health of a population, look at the air they breathe, the water they drink, and the place where they live. Actually, that basically the first approach of One Health, because we are living in the natural environment. We are depending on the natural environment. Therefore, actually, geology is part of the natural environment. We are studying rocks, minerals, soil, whatever, what are the component of the geology. And therefore, geology is one of the most important part of the environment. Now, with that, actually, a subdiscipline has been introduced to study the interrelationship between Earth and the health of population or maybe organisms that we now known as medical geology, which is also one important part of the One Health concept. Okay, medical geology usually defined as the science dealing with the relationship between natural geological factors, what I have told you earlier, the chemistry of soil, chemistry of water, and then health in humans as well as animal. And also in medical geology, we try to understand the influence of environmental factors and also the geographic distribution of such health issues. But medical geology is a what we call a broad and complicated subject, which requires interdisciplinary contribution from different scientific fields. As you can see here, geology is only a part. Actually, the main contribution from earth scientists or geologists is investigating the geology and as well as the geochemistry of element in the natural environment. They also investigate the irregularities in their regional distribution as well as their geological or geochemical characteristics, and also influence in animal, vegetation or crops, as well as health of humans due to excess or deficiency of certain chemical components in the natural environment. Okay, basically medical geology studies the effect of environmental factors on the health of individuals or communities. For example, in particular, it examines the environmental impact of macro or micronutrients in the geosphere, hydrosphere, and atmosphere, or in other words, soil, water, dust in the air, which can have positive or negative effect on human growth, development, and general health. Just explaining that rocks and minerals are the basic or fundamental blocks of the Earth's surface, full of important minerals, chemical constituents. Remember, all minerals are inorganic solid compounds. Rocks breaks, broken down by weathering processes and then form soil. The chemistry of soil always depend on the parent rocks and where the soil, which is actually where the crops and animals are growing or raising. Now, drinking water, if you consider drinking water, which travels through rocks and soil as a part of the water cycle. And then most of the elements are taken into basically human body through soil, or maybe it is basically through the plant as shown here, or it may be related with the animals, or it may be direct influence from the atmosphere. Okay. Now, there is an important concept in medical geology, and as I mentioned you earlier, some of the elements we required from the environment. Now, and some are not required at all. Therefore, we basically categorize in geochemistry, we categorize as essential element or toxic element. If something is not wanted for the health of people or to organisms, we consider it as a toxic component. If you consider certain element like calcium, magnesium type element, if it is deficient, then we will have negative health effect. But if you have the maximum or what we call the optimum level, then we have a very good health. Even if these such elements are, if you are getting in higher doses, we will not have much detrimental problems. But if you consider certain element like fluoride, selenium, iodine, or molybdenum, such kind of element, if it is deficient, we will have certain health issues. And then we need a certain optimum doses for our well-being. And if it is exceeding certain level, it becomes toxic. And then we have another type of element we call the toxic component, what we don't require for our functions or body functions, like cadmium, lead, mercury, those kind of element. The body can tolerate up to certain limit. Nothing will happen even if it is not receiving. But what happens if it is exceeding certain limit, then it becomes a toxic component and causing severe problem. Actually, Paracelsus, who is considered as actually a father who made use of minerals and other chemicals in medicine, he said there is a poison in everything, but dosage is the matter. Even if you take water, excessive water, it can become toxic. Even if you get high amount of sugar, high dose of sugar, even it can be toxic. If you consider the geological components, water is the most important part because we are getting mostly water from the ground. Particularly in developing countries like in Sri Lanka, we obtain most of the drinking water from the ground, where water is trapped in geological layers. Of course, we all know that water is basically hydrogen 2 parts and oxygen 1 part, but there are third things that make water actually, but nobody knows what is that. That third component is very important. Those components may having positive or harmful effect on health and well-being of living organism. Now, this third component in water can be added due to several reasons. It may be from the geological material we call parent material, dissolving of rocks, because rocks are containing minerals. Those are inorganic compound. Water is what we call a excellent solvent, and minerals can be dissolved and certain component can add into water. Even agricultural activities, human activities, fertilizer application, pesticide, mining activities, industrial waste, or wastewater can add certain chemical, that third component into water. But what happens if you are getting excessive doses or even low doses in certain element, we will get certain health issues. I'll discuss few health issues with some example where geology is interrelated with the health of humans. Now, for example, fluoride. Fluoride is one of the very important component. We considered fluoride as an essential element. But if we are receiving in excess dose, particularly through drinking water, it become a toxic component. For example, more than 30 million people in China suffers from dental fluorosis due to excess fluoride in drinking water. This fluorosis is mostly related with geochemistry of groundwater compared to any other factors. Many countries, particularly like Sri Lanka, some African countries, we can observe dental fluorosis, mottling of teeth, brownish colored teeth. This is actually a child from, again, Sri Lanka. You can see how he's having this brownish colored teeth. It is actually not a deadly type disease, but it is unsightly. Particularly, this is very common in dry zone people. Then this is again an X-ray picture taken from a male skeletal fluorosis. You can see that basically the white color basically showing the generalized increasing of the bone density as well as cortical thickening. And also you can see this bridging osteophytes. The person cannot move clearly because of this bridging osteophytes in the spine. And this is again very, in certain places, it is common in Sri Lanka. This is actually not only humans, but animals also affected by high fluoride. This is not, these pictures are not from Sri Lanka, but we don't know actually the situation in Sri Lanka because we have high fluoride regions. Sometimes animals are also having fluorosed teeth because of they fed with high fluoride water. Now, if you consider the limit of fluoride, actually it's a very narrow range. Now, if it is we are receiving lower doses, then it will cause dental caries. We call dental caries decaying of tooth. That's why this toothpaste advertisement, we can always hear that fluoride contained in toothpaste, something like that. But the optimum range is, this is WHO range actually, 0.5 to 1.5. It's a very small range, just 1 milligram per liter. 0.5 to 1.5 milligram per liter is the optimum range that was described by the WHO. If it is exceeding, then we'll have dental fluorosis or skeletal fluorosis and also pain in back or neck bones like that. But a country like Sri Lanka, those levels, WHO levels are not acceptable because we are drinking, because we are in a very hot climatic country and we are drinking too much of water. Therefore, our values should not be actually in between 0.5 and 1.5 milligram per liter. For example, Sri Lanka, it was found that even above 0.6 milligram per liter, very small dose, even 0.6 milligram per liter having can cause dental fluorosis. Okay, this is actually distribution of fluoride in Sri Lanka. You can see all these red dots in the dry zone of Sri Lanka, particularly having excess fluoride even greater than 2 ppm. In some places, it might be much more higher, depending on the geological condition. Then another case related with the medical geology is the arsenic problem, arsenic exposure. Arsenic is one of the highly toxic but geologically important element, and geological material can add arsenic into groundwater, causing severe health issues among consumers. Arsenic-related problems were first reported in Bangladesh in mid-90s among groundwater consumers. And it was noted that in some districts in Bangladesh, over 80% of the wells containing greater than 50 microgram per liter arsenic, and 8% of the wells had arsenic concentration greater than 300 microgram per liter. And it is considered as actually one of the world's biggest environmental disaster. Millions of people in Bangladesh, West Bengal, also in India, certain part of India, affected due to high arsenic. Actually, WHO recommended level of arsenic is 10 microgram per liter, actually 50 microgram per liter, even 5 times greater than that. Now, if you consider Bangladesh, you can see all these red dots. This is actually done by the British Geological Survey. As I mentioned you earlier, geologists can map the concentration anomalies. They can identify anomalies. And you can see all these red dots are having over 50 microgram per liter arsenic. And remember, actually, WHO accepted limit of drinking water is 10 microgram per liter. In Sri Lanka, actually, fortunately, we have high-grade metamorphic rocks that do not contain arsenic-containing minerals. As in the case of sedimentary terrain, like in Manna Island, you can see some of the wells are having higher than the WHO recommended concentration. You can see these dark brown color spots are which are having high arsenic concentration. Okay, now coming back into the soil, this is another problem we call podoconiosis, which can be observed in certain African countries. It's a kind of a swelling of lower leg that is triggered by certain irritant mineral, basically titanium oxide, titanium bearing mineral. Actually, these people are working on bare ground without wearing footwear, any footwear. That soil we call red soil, which is containing high amount of certain minerals, particularly as I mentioned earlier, it's titanium oxide. And that particles can enter into the legs and then causing this swelling of legs. That disease is called podoconiosis. This is again a best example where we can observe the geology or soil which is affecting on the health of people. Okay, now another interesting issue is we call biting of the earth by animals as well as some humans. Basically, that is known as geophagy. It is actually deliberate or regular consumption of earthy material such as soil, clay, mineral substances by humans or animals. Among animal kingdom, actually, this is a very common thing among elephant, for example, chimpanzees, gorilla, birds, even some domestic animal like dogs. They eat earth or soil. Still, we don't know why they are eating this. And sometimes, even in African countries, some people even consume earthy material. Still, it's a problem why they are use this clay. And this is another set of pictures what we have taken from Udawalawe National Park. Now, basically, we know that elephants are browsing grass, but you can see this herd of elephants, they are eating soil. They are eating soil from a certain selected location. Not everywhere. They select certain locations and then they consume soil. That is another interesting case what we can observe in medical geology. And then finally, actually, I wish to give you attention to natural radioactivity. Now, in the picture, you can see a mineral with what we call aconite. Aconite is actually discovered in Sri Lanka, one aconite some years back. Now, basically, aconite containing radioactive element like thorium and uranium. Now, if you consider the average annual estimated exposure in US from background radiation, from medical background radiation as well as medical sources and other consumer product is usually 360 millirem. But if you are putting about 500 carat, that means about 100 gram of aconite over 20 hours, that the dose what we expose, radioactive dose what we exposed is very equal to the average annual estimated exposure. Now, if you are wearing 5 parts of aconite, that is just 1 gram, that take little over 83 days to reach this average background dose. Therefore, some of the gem minerals actually are radioactive. Because of this radioactivity of aconite now, we are not considering aconite as a gem mineral, although it is a very bright green, beautiful gem mineral. And okay, in this short presentation, I tried to give you some examples where earth material have an impact on the human and animal health. But geologists basically bring it's an interdisciplinary subject, and we can understand the chemistry of earth material or distribution, what we call the anomalies of chemical component in the natural environment. And also geologists can understand the complex interface, interaction of substance in the natural environment. And finally, actually, I in this short presentation, I try to give you some examples, but there are so many examples we can provide where humans and animals are interacting, or where they are having certain problems. For example, high nitrate levels in drinking water and cancer, or blue baby syndrome, water hardness and incidence of kidney stones, selenium, deficiency of selenium and malformation of nails and hair in human, selenium and vascular dystrophy in wild animals or farm animal, and silicosis due to inhaling dust, particularly with volcanic origin. Those are some of the cases, but because of the time limitation, I don't have much time for the discussion. In conclusion, I would like to say we are dependent on our planet Earth in one way or another, because we live with the Earth means. Therefore, our health always depend on it. Finally, I thank you for your attention, as well as I would like to thank Dr. Jayanthi as well as Dr. Bandara for coordinating this event and contacting me always, and giving the opportunity to present this short presentation to you. Thank you for your attention.
Educate us now. So let me introduce Dr. Sajith Edirisinghe to the audience. Dr. Sajith Edirisinghe is a senior lecturer at the Department of Anatomy, Faculty of Medical Sciences, University of Sri Jayewardenepura. And he was the secretary of the SLMA last year. And he's a medical doctor and a clinical geneticist by profession, with a Bachelor of Medicine, MBBS, basically, from Jayewardenepura. He has master's degrees in clinical genetics and health administration. And Dr. Edirisinghe has a PhD. It's from the area of oral cancer genetics. I think it's a split PhD from Japura and Otago, New Zealand. He has a special interest in microplastic effects on human tissue. Author of many books. Dr. Edirisinghe's latest book is on microplastic and you, coming from a joint project by SLMA and the Ministry of Environment. He holds a patent for a new technique in human tissue plastinization, coming from his research on human tissue preservation and plastination techniques, and on core genetics. So it's my pleasure to invite Dr. Sajith Edirisinghe now to deliver his presentation.
For that kind introduction. So I will take you all through a small hot topic on these days: a man-made disaster, the unseen effect of a seen disaster. So first of all, I just want to declare most of these photographs are taken from the internet only for educational purposes. So we will be talking about microplastics, where we will talk about the plastic material, which is in 10 to the power minus 3 to 10 to the power minus 9. So basically, these microplastics are theoretically divided into primary and secondary. Primary in the sense, at the factory level, they produce it in a less than 5 millimeters in diameter. And the secondary microplastics in the sense, those are the plastic that we throw away into the environment and they get crushed by the vehicles and exposed to the sunlight, UV radiations, and because of many other factors, these plastics are broken down into tiny pieces of particles. So those are called secondary microplastics. So these microplastics were there in our environment from the beginning, but we didn't know about that. Luckily, this gentleman, Professor Richard, discovered these microplastics in 2004. Until up to 2004, whatever the plastic material that we have been using, we were just giving it to the municipal councils, or we must have burned them, we have thrown it away to the environment and produced huge amount of microplastics. But luckily in 2004, this gentleman has found a thing called microplastics. But today is 2024. Have we done, after knowing about these microplastics in 2004, have we done enough to reduce these microplastics? Because we can excuse until 2004, we didn't know about that. But from 2004 to 2024, have we done enough to reduce this problem? So if you look at this particular data, even if you start by 2023, it will take many years to stop this microplastic pollution. But we are no more closer to that target. So you all can see how these graphs are escalating. So this is just a basic overview how this primary and secondary microplastics are developed. So these microplastics are there in our face scrubs. It is available in Sri Lankan market as well. I don't want to mention the brand names. And it is available in toothpaste also. It is available in Sri Lankan market. If you go to whatever the supermarket, you can find these things. And also, I hope you all are much aware about this Express Pearl disaster, where we got a lot of microplastics into our environment. Still, we do get microplastics, the tiny beads, into our beaches. And this is the microfibers that we put out. That is the biggest threat to the environment from our nylon clothes when we wash. So that is the huge amount of microplastic particles that contaminate the environment and enters to the human body. So this is the secondary microplastics, because certain people burn them and it is get crushed and exposed to UV radiations and everything. So the problem here is by 2018, less than 10% went for recycling. This is the entire world, the plastic waste. But the thing is, more than 90%, even this is true up to now also, more than 90% are either dumped at landfilling or burned. I hope you all are aware about these images. You all must have encountered these images in 2023. These are images taken from the internet, and these images are whatever the misty environment we got in 2023 because of the polluted atmosphere. These are because of the particulated matters, right? It could be came from India or somewhere else, or generated even within Sri Lanka, the dust particles, the particulated matter. So in this environment, we had huge amount of microplastics. Don't worry, we have breathed a lot of microplastics from 2003 during this disaster, and we are very happy to tell everyone has microplastics at the moment in our body. So still by 2004 to 2024, we have done very limited amount of work to stop this pollution. So these are fluorescence microscopic images where these tiny microplastic particles get into the environment, and these tiny microscopic creatures think these are their food. So these zooplanktons will start eating these luminous green color dots are the microplastics, and this is the microplastics in these animals. This is the gastrointestinal tract of this animal. So it is full of microplastics. So you all can see these are in their bodies. So what happens now, this food chain we have learned during our A-levels or O-levels. So this is what we call as bioaccumulation. So the man-made disaster, the environment hasn't taken anything what we have disposed. They have, the mother environment has grinded it into the tiniest most particle, and they have, she has fed the plastic particles back into us. So we have to remember that. So now in humans, we are the apex predators in these food chains. So we do get these tiny microplastic particles every day into our body. This is a study done in China, a lagoon. So you all can see how much of plastic particles are there in the grill or the stomach or the intestine, depending on the type, the food pattern of this fish. So you can see the fragments, the films, that means from your lunch sheets, and the fibers from your nylon clothes. This is a study done in Sri Lanka. Remember, this is Express Pearl disaster happened in 2020 after this publication. In 2021 or 2022, Express Pearl disaster, but this was published in 2020 from Peradeniya. See, it is funded by National Science Foundation. This research says, irrespective of the brand that you buy, the salt, the table salt, irrespective of the brand that you buy, everything is contaminated with microplastics. So daily we are eating microplastics. So this is a report from WHO. 160 pages. It is available at the internet. You can freely download it. They have specifically mentioned in drinking water, we have microplastics. This is a research. Just to show you all, I have put the DOI number so you can very easily search for the full paper. So you all can see they have taken the plastic water bottles from India, the China, Thailand, Indonesia, and they have purchased from online also, Amazon, right? So they have checked for each and every water bottle, 500 ml water bottles. Every water bottle contained microplastic. Luckily, this study didn't contain Sri Lankan water bottles. I'm pretty sure if we checked, the Sri Lankan water bottles will come to the top, because you know how it is packing is done in Sri Lanka most of the time. Right. Now, from the food and water, these microplastics will enter to the human body. Once it is entered to the human body, there are different mechanisms how these nano-sized particles will enter to the past the gut epithelium. So, for an example, this is your gut tube. So you have the particle, the tiny particles. These are the epithelium lining the gut tube. So it will pass and it will enter to the blood vessels. So once it is entered to the blood vessel, that means it's like that you have entered to a highway. So if you enter from Kottaba, you can exit from either Hikkaduwa, Gaul, Matara, Hambantota, whatever the place that you like. So once these tiny microplastic particles are in your blood, this can go and deposit in your kidney, lung, brain, wherever you name it. It can deposit. So this is an animal study I just want to show you all. These animals or the rats were fed with microplastic particles. You all can see these luminous green color dots. These are the microplastic particles. The fluorescence imagings are there. So the 20 micrometers and 5 micrometer particles. So these animals were fed with microplastic particles mixed with their normal routine food. So after that they have taken the tissues and they have checked for the microplastic particles. So you all can see from the gut it has entered to the normal blood and it has gone through the entire circulation, and here the liver tissue, you have the kidney, and this is the gut. You have the this is exactly what is happening in humans currently at the moment also. This is another zebrafish study. I just want to show you all what is exactly happening. This is an animal model that we use to mimic and get the results quickly to see what is exactly happening. You don't need rocket science or science knowledge to understand this. So for example, just an image comparison, just you all need to understand. So this is the normal right. Now this is the normal control. You all can see the dark bluish color. This is the epithelium which is continuously there in the gut tube. This is the cross section of the gut tube of this zebrafish. Now if you look at these red arrows, what has happened? The epithelium has been destroyed. This is exactly what is happening currently at the moment in our gut. So when we ingest these microplastic particles, that will destroy our gut epithelium. This is just to show you all, because we can't show it in humans because it is unethical to do a human modeling. So that is why we have gone for zebrafish. That is from your food and water. Then we come for the air. Even at air, these tiny microplastic particles can go to the alveoli levels. These alveoli levels particles will again, it will cross the epithelium and come into the blood. So once it is there in the blood, what happens? It can go anywhere around the body. So this is another study that they have done for the mice. They have taken pregnant rats. They have taken pregnant rats and they have allowed to inhale microplastic containing air. For these pregnant rats, they haven't given food contaminated with microplastics, but the thing is they have put into a chamber which is, the air is contaminated with microplastic particles. Now see what has happened. I don't know whether you all can see. These are the tissue parts of the fetus, the baby rat. We have allowed the mother rat to inhale the plastics. And we have taken the baby rat's tissue and we have, you all can see these white color dots. I don't know whether you all can see it properly. So these are the microplastic particles which were inhaled by the mother rat. It has gone to the mother's blood. It has crossed the placenta and gone to the baby, and see, it is in the brain of the baby. This is exactly what is happening currently at the moment in humans also. But we don't understand the gravity of that. Now there are plenty of evidence to show these microplastic particles are crossing the placenta. So how much we eat? Irrespective of the age, even you're an adult or a child, the air that we breathe is the commonest method of entering of microplastics into the human body. So it is not the food, the air that we breathe, right? So by 2023 we had this mist, the air quality dropped drastically. So we contaminated ourselves like nothing. So air is the most problematic thing. So we get huge amount of microplastic particles through our inhalation. So also now, if you all can see, the salt is also there, and the bee honey. Bee honey is also contaminated with this microplastic. So this is in adults, this is in children, irrespective of your age, you are getting exposed. So they have gone into further details to see what type of plastics that we are in danger. If you all see, even you take alcohol, air, water, your seafood, whatever, the highest amount of contamination is from your fibers. It's from the nylon fibers that we put out into the environment. This is basically for females. We use a lot of makeups. We use makeup to cover the damaged skin. This is another study that they have done. The smaller the particle, it can enter. This is the skin. This is the skin, and these red color dots are the microplastic particles. It will go through the damaged skin. We use makeup to cover the pimples or whatever. Pimples are, that means it's a damaged skin. So you use whatever the number of layers to cover it. Certain the makeups do contain microplastic free makeups, but most, this is Sri Lanka. So we have huge amount of microplastic containing makeup material. So through the damaged skin, it can enter to your human body. So from air you breathe, the food that you eat, and through your skin, these microplastics will enter to your body. So what's the problem? So these microplastics are like magnets. So somebody can tell it's just a plastic material, it just come in and just go. No, it is not like that. These are like magnets. So whenever they are in the environment, they are like magnets. They will absorb whatever the heavy metals, whatever the carcinogenic material in the environment. So how does the heavy metal comes? It's again by the human mismanagement. Your batteries, lead acid batteries that you put, your CSF bulb, that you all just throw it away into the environment. So it contains a lot of heavy materials. So it is there in the environment. The plastics are there in the environment. These two are very friendly fellows. So these are like magnets. They will combine. So longer the duration that they await in the environment, they will go along with this plastic material. So there are proven evidences, the bisphenol A, a chemical that they use to create these plastic bottles, the breast cancers and everything. So how does this work? Once this plastic material enters to your body, what happened? We have done this practical during our school days. This is potassium permanganate. We put a small piece of potassium permanganate into a clear glass of water. And what happens? After some time, after 15 minutes, it's simple diffusion. So from the highest concentration to the lowest concentration, these plastic material that contains all these heavy metals or carcinogenic elements will go and deposit in the lung or the liver. So the liver doesn't contain all these heavy metals. So from the highest concentration to the lowest concentration, these heavy metals and these carcinogenic elements will start diffusing. So this is how you all will end up. The breast cancers, the lung cancers, the liver cancers, GIT cancers, you name it, it's there. Not only the cancers, these chemicals can mimic your testosterone and estrogen. There can be problems in your reproductive health, the subfertility. So there are plenty of things that can happen from these microplastic particles. And also, I just want to show you all what will happen when these tiny microplastic particles enter into your body. This is what we call as corona formation. Once this, the dark black color one is the plastic material, and surrounding that is the corona. It's like a crown. That is why we call it as a corona. So all these your plastic, around your plastic material, all these proteins, the serum proteins and all sort of chemicals in your body will clump and will have a huge amount of reactions within your bloodstream. There are free oxidize, the free radicals formation it will break down into smaller pieces, they will clump together. There are many reactions that we don't know. This is exactly what is happening in our body. So how much do we eat? Per week, at least we eat 5 grams. Eat, inhale, and through your skin. So now, when you go home, just calculate how many weeks that you have lived up to now, and think how much of plastic that you have inhaled or eaten or whatever, ingested. So this is a rough calculation from the Newcastle University of Australia. So this is just a rough calculation, 5 grams. It's just the size of your ATM card, but it will increase with the depending on the amount of population area, the pollution, the amount of pollution, the area that you live, it can go up to 10 or 15. So this is exactly what will happen in future. They have predicted in 2025 by next year, for each 3 metric tons of fish, at least 1 metric ton of plastic will be there. So this ratio will come down very soon if you don't do anything. So don't think all the plastics will start floating. Some will deposit at the seabed. These are the continuous emissions of microplastic. Until this particular plastic bottle is gone or destroyed, it will keep on emitting microplastics. Because with the currents, this will go and hit on the rocks, it will emit microplastic. Also, by 2013, a new word, plastisphere, was introduced to the dictionary. That means whatever the plastic material that we throw into the environment, the marine ecological animals will come and try to live on that. So we are not worried about these snails or all these small fellows. They are not that much harmful. But we are worried about whatever the microorganisms that will start living on the marine debris. There are many viruses, there are many bacteria that can live on the food wrappings that we will throw it away. For an example, the lunch sheets that we throw it into the environment. So there are Vibrio species, Vibrio cholera. There are Vibrio species that can very easily live on these microorganisms. So these food materials that can transport different types of antibiotic resistance from one continent to another. So for an example, have a look at this antimicrobial resistance. So this amoxicillin, everybody knows about this amoxicillin. See the resistance, it's more than 90. So we are running out of antibiotics to give. Because these creatures will develop resistance, and that resistance can be transported from one continent to another through these plastics. So we are at a danger. So the other thing, certain publications have come out about these viruses living on these microplastic particles. For an example, COVID-19. So we just told, okay, you had a direct contact with this particular person and you spread to the 1,001 people. But for an example, if you think, if you revisit the incidences that happened in the past, you just get to know, okay, the outbreak is there, the China, on the next day it has gone to America. So this could be one of the reasons. Still some studies are coming up. So this 2022 publication, so we haven't confirmed it. So this could be one of the reasons where this microplastic particles spread rapidly, helped in spreading this COVID-19 virus. It could be used as a biological weapon. So have we done anything? So 1960s to 2004, okay, we can excuse people, okay, we didn't know something like that. But 2004, this particular person told there is something called microplastic, so be aware. So until up to now, have we done our job? Still this curve is going up, we haven't done much. This is a photograph that I have taken in 2020, just before the starting of your COVID, in Kokilai, Eastern Beach, just below the Mulathu, where I went with my medical students to clean this beach as a charity project in Sri Lanka Air Force. You can't clean these things. So if you pay attention for these letters, can you all read them? These are not the water bottles used in Sri Lanka. So imagine, I don't know these letters, which country does this belongs to, probably from Indonesia or Malaysia or Vietnam, I don't know. So probably 1,001 kilometers, these were there at the Kokilai beach. So what we have done, we are also putting all these plastic materials, and those plastic material must be ending up at India or even at UK. So those people must be blaming these stupid Sri Lankans are putting everything into the sea. So as we are blaming to these people, they are just dumping everything into the sea. So these are the materials that can transport your infections, and it can transmit a lot of antimicrobial resistance. This is the book that we have written with the help of Ministry of Environment. It is available on the website, Sri Lanka Medical Association website. You can freely download it. We know only the tip of the iceberg. Because until 2004, we didn't know there was something like this. So up to now, we know only up to the tip of the iceberg. There's plenty of things that we have to look into. So it is about reduce, reuse and recycling was the old system. And also I would like to highlight refuse. If you don't need it, just say no, thank you. I have brought my bag to collect my goods. So rethink, is it really essential for me to take this particular plastic particle? Or else, this is where the engineering and the technology and the management people come in, redesign. This is not a problem that only the medical community can handle. This is where the marketing people should come. This is where the social science people should come. This is where the engineering and the technology people should come. Because the social science people, those are the people who can create this into a live drama or a song or whatever, where you can transmit this scientific knowledge into the lay people's mind. So this is where the technology people come. They can trap these things. They can develop some alternatives and everything. The marketing. This plastic waste is a huge amount of money. A lot of entrepreneurship can be developed. So you start from your home. This is my home. So you have all these tiny baskets. So one for the flexible plastic. This goes to Valachena. The paper waste. We have the tins and everything. And I have two baskets for the electronic waste and for the glass. And you take it to the university also. This is my working place. So Faculty of Medicine, Jayewardenepura. You take your habits into where you work. So we collect, now we have sent nearly 700 kilograms of this plastic waste. We have asked all the students and the staff, bring whatever the plastic that you can't throw it away into the environment, just dump. Here we have a system to dispose. This is again the electronic waste collection at the faculty. So it's just a simple thing, just take these A4 boxes and given it to the departments. They collect all these non-inventorized items, the electronic CDs and batteries. We have the glass waste also, huge amount we have sent more than 2 tons of glass waste for recycling. This is the only and first Rigiform collection bin at the university sector. At Jayewardenepura, we have huge amount of Rigiform, where we do get all these laboratory bottles, the alcohol bottles and everything coming in Rigiform packagings. So it was previously dumped here and there. So even in the municipal council people also, they are also not taking Rigiform. It's a huge problem. So we have one company located at Kalutara, they recycle Rigiform. The only thing that cannot be recycled in Sri Lanka is fiber. All the other materials can be recycled. And I'm very happy to see the recycling bin in front of SLAAS. So it's a very good thing. This is a paper waste. It's near the Kirlapana. You can just dump your whatever the waste material, the waste papers. So I use as a practice to give them. So you can recycle the glass waste. The importance of recycling of the glass is because if you melt this silica, you have to melt it nearly 2000 Celsius. But if you use the recycling material, at least 300 Celsius will be much more lesser. We use less amount of energy, less amount of pollution, less amount of heat loss into the environment. So as a practice, please try to use the glass bottles and help to produce this refilling feature. Never use this. Don't keep your plastic bottles in the vehicle because with the heat, the inner layer of these plastic PET bottles are shedding off, so it's not good. So try to go for a lunch box rather than a lunch sheet. So this is where the technology comes in. So bubble barriers. So it is happening in certain countries where we also can do this. We can put these bubble barriers along the lakes. This is the simplest and cost-effective method of trapping all the microplastics. So we have seen they are putting some barriers, the floating barriers to catch the plastic. That will catch only the floating ones. But the plastics that will go underneath at the middle column of the river will directly pass into the sea. But this method can trap even a single tiny microplastic particles and bring it to the top, and you can go for collection sites. So engineering, the tire dust, the next problem. So there are people who will start developing to catch the things from the tire dust. And also we can use these type of materials to catch all the microfibers. These are available in Sri Lanka. So just use it in your washing machine. This will catch all the microfibers. It will trap. Just a small suggestion for the SLAAS. How about a photography competition about the plastic pollution on human and wildlife, the biggest man-made disaster. So these are the out-of-the-box thinking, innovative things, because we can transmit, if we open it to the school children and for everyone. So I hope this photograph, I took it at DSR Talatugoda 2 months back. So see, the baby and the adult. We are killing them. So thank you so much.
Yeah, thank you so much, Dr. Edirisinghe. Please have a seat and I think both speakers are now available, Professor Chandrajith online and Dr. Edirisinghe here. So now if you have comments, questions, anything, now it's open for a discussion, maybe for a short time.
You showed some crustaceans, and you said that the fluorescent material inside the crustaceans is plastic. But even for oil pollution, you see the same thing. So how can you really differentiate between oil pollution and plastic pollution? It can be even oil pollution.
These are different lenses that the fluorescence, the wavelengths that they have used to detect only the plastics. So these are the plastic materials that they have used. So if you change the wavelength, you change it.
Now, it's alarming to see that, the nanoparticles, nanoplastics are in blood. Now, can't you use this dialysis-like technique to basically filter whatever the blood, where you can be able to very easily capture the nanoparticles like enzymes or maybe enzymes like any other material, by which you can be able to, just adsorb whatever the plastic, so that you will be getting the nanoparticle free blood going back. So why not develop? So you're going to get a good, future because everybody has to go and then get this dialysis done.
Yeah, that's a good thing. But the thing is, you have to insert a neckline or you have to develop a AV fistula for everyone. Because, for an example, if I do that filtration today, from tomorrow onwards, I'm again exposed to the same environment. And from tomorrow onwards, I'm getting the same amount of plastics. And on the next week also, I have to go to the general hospital and get it dialyzed again. And so I have a lot of trouble.
We have been basically collecting like 20 years of nanoparticles in our blood. So I mean, doing this would help you remove at least a certain fraction, which might again take another couple of years to, go to that particular highest level. So therefore, this is what Elon Musk is doing. I have read that Elon Musk is doing this to, remove all the contaminants in the blood.
Yeah,
Because what he wants is he wants to live 100 years.
Yeah, that's a good suggestion. But the thing is, now, once you remove them, you have to make sure that you are living in somewhere around a good environment.
Because if you have been doing it whenever you have a kidney problem, similar one. I mean, I think there is a green light which comes very soon to, this dialysis like filtering even for the nanoparticles.
Yeah.
But there is another interesting thing because it gets incorporated into the cells. So that won't come out with the dialysis.
That won't come out.
So it will be in the tissues. The problem
it will be
is it's not
deposited in
yeah,
the tissue. You can't take it out. The
It's
thing
inside the cells.
And now the technology is there to capture the nano ones, but the red cells are bigger than that. So eventually red cells will be trapped in these filter materials. And the thing is now we don't know about the picoparticles. We haven't thought about, because initially we thought about this 10 to the power minus 3. Later on we got to know there is something called 10 to the power minus 6 also in our blood. Later on we got to know the power minus 9 is also there, but we don't know about 10 to the power minus 12 is there or not. So it's a good suggestion, but it's important to think, but there are limitations also.
I mean, this is one reason why from the medical point of view, we are very concerned about all these pesticides and glyphosates and pollution. We don't know what is happening. With these microplastics now, for example, I mean, even the microbiome, the microbiome changes, and as you quite rightly mentioned, they can act as, transporters of all these viruses and things. So when there is mass exposure like this, we really don't know what happens to us. So we have to be very cautious. I mean, everybody told us that plastics were safe. Even now, most people will think it is safe. See? This is the danger. Yeah.
Yes, that's the thing.
Now, since the MV Express Pearl disaster, maybe in the coastline, as you said, there can be more microplastics in air than before. So have you done any study to see the difference before and after? Do you have any information
The
before
NARA
what
has
was available in air? And now are you doing anything to find whether the amount of microplastic in air is higher?
The NARA has done a lot of studies on that.
According to my knowledge, I did not see anything coming.
Yeah, anything didn't come out.
Yeah.
Because I have several contacts with NARA, because they have done several studies about this pollution.
Okay. And the other thing is, you showed histological slides where you said that the epithelium is damaged.
Yes.
Is it due to abrasion or why? How can it happen?
It could be due to many reasons, because of the microplastic particles come and directly because of
No,
the
now
abrasion.
they are taking them actively into the tissues, no? They're
Because of
taking
the
these large particles
toxicity
actively
it
into
can
the
damage.
tissues. Yeah. But now you said that it's broken into pieces.
Yes, it has broken into several parts because it could be because of the abrasions, or they will take it actively or passively. Because of the toxicity, the cells will start bursting out.
Okay.
Could be many reasons.
Many reasons. But now actually now it's better to do something about fish also,
Yeah.
because now the plastic is buried under the sediments. Burnt plastic is buried under the sediments,
Yeah.
it's coming out.
Yes.
And also the toxic algae can
Yes.
grow on the,
Yes, exactly.
and we will get the toxins very easily and
Yes.
also the plastics very easily through eating fish.
Eating fish, yes, definitely.
I have a whole lot of questions, but I don't want to take all the time. First of all, if we apply the DDT model, where 10% of the insects were not prone to the toxicity of DDT and they managed to survive. And they later on became the 90% of the insect population. So as a result, we now have a population that is immune to DDT, insect population. So similarly, you said that one of the bad things about these microplastics is cancer. Now, if everybody is ingesting this in a uniform manner, can't we use the model of the cancer patients and how much of those cancer patients have developed cancer due to microplastics, and then determine how much of the community is immune to microplastics? That's number one. Number two is the alternative to the water bottle, plastic bottle, was the glass bottle. Has anybody done any studies about microglass and whether this is body can cope up with that? Nextly, the body has a fantastic way of getting rid of all the impurities. If it can't get rid of it, as you said, it forms a corona around it so that it forms a protective shell to prevent it from causing further damage until it is discharged as a wound or something like that. So whether that is a viable, whether there is that kind of response to microplastics. So 3 questions, I'll stop for the time being with them.
Yeah, for the thing is, for the cancer immunity, that is the area that we have to think of. So I don't think because of the immunity, these cancer material, the genetic material will change from the whatever the chemicals that we have used to develop plastics, as well as the things that they have absorbed from the environment. So that chemical can do the change in the cells. But the thing is, at the moment, we have no evidence to show, because it will take long time, because the human models also will take long time to show the collective, the cocktail, because we have no evidence to show how much of microplastics that we are eating at the moment, because all these are models, the predictive models. Because from when you take a cup of tea, it totally depends how much that you ingest from another person. So these plastic materials, it will take long time to give us the observation. Even for a cohort study also, it will take long time to tell, because to prove these microplastics, these from the plastic material, it will get immunized and it will help to prevent cancers. For the moment, sir, I don't have an answer for that. Even for the glass, microglass, still the people are looking for that. Still, we know very little amount of things. Not in Sri Lanka. Very less. Very less. People, even up to 2004, we didn't know there was something like this. So the people, now only the people are thinking in different lines. So probably now we are thinking about picoplastics rather than just this microplastics is just a simple term. Now people are thinking about picoplastics. We don't know what will come in another 5 or 10 years time.
Okay, let's find out whether there are questions online, and also are there any questions to Professor Rohana Chandrajith? Professor Chandrajith?
Professor Chandrajith, actually now
Yeah, I can hear.
we bring coal from other countries.
Yeah. I cannot hear the question. මට ඇහෙන්නේ නැහැ. මට question ඇහෙන්නේ නැහැ මොනවද? Yes, it's possible because coal also containing high amount of arsenic, but it can be added into ash actually, ash and into uh, uh, the air, particularly during the burning process, because arsenic is highly volatile, and yeah, it can be added into the atmosphere. Okay. Now, basically, yeah, of course, coal containing a fairly high amount of arsenic, but burning processes can add arsenic into the atmosphere as ashes or as a gaseous component, because arsenic is a highly volatile compound. And not only arsenic, but coal is also containing high amount of fluoride. Now in China, actually, coal burning, the coal they use for home heating, house heating, and
Be a source of arsenic for local people.
pardon, madam, Professor, Prithviraj, can you ask the question again? I cannot hear actually whole question.
We can. Okay. Actually, there is arsenic areas. Actually, now when people are taking water from tube wells, in actually dry areas, they are taking water from tube wells to for agriculture, especially to grow onions and things like that. So, can arsenic come in through aquifers? Can the arsenic come into water? And then when they grow onions using that water, can onions contain arsenic? We are bringing the onions from Jaffna to other areas.
Yeah, it's possible, but the concentrations, particularly in Sri Lanka, are extremely low, because we found high arsenic only in Manna Island. Jaffna also having some wells which is having a little bit higher arsenic than the WHO recommended value, but it depends on the accumulation, bioaccumulation, the properties of the plant, because some plants can accumulate arsenic more compared to other plants. For example, rice is a plant which can accumulate arsenic in grains. But fortunately, in Sri Lankan water, arsenic concentrations are extremely low, except in these sedimentary regions like Manna Island or Jaffna. But again, it is not like in Bangladesh case.
Radioactive material in monocyte, will it affect people in the area? There is radioactivity in monocyte in Godavari area. Actually, has it,
Yeah,
is it causing any effect on people in the area?
Yeah, it's possible, but I think in monocyte, the background radiation dose is not that high, it's normal. But if you go to, if you consider Pulmude, and Pulmude is containing, I think, more than the background radiation, more than the background levels of the radiation. But for example, in India, particularly in the Kerala beach, they have this heavy mineral sand deposits that that was reported that the background levels are higher than the normal. Yeah, some gem minerals actually
you
like
so much,
zircon,
Professor
which
Chandrajith.
may have some high levels. Yeah.
Any
Yeah.
questions online? Anything online? No? Okay. I think we will basically officially try to wind up. So I would like to thank again both Professor Rohana Chandrajith and Dr. Sajith Edirisinghe. Can we give them a round of applause again? Thank you so much. Now, before delivering vote of thanks, I think another little event that we have to do, that is to basically give a token of appreciation to both speakers. May I invite General President Professor Ramani Vijayasekara to give a token of appreciation to Professor Rohana Chandrajith. Professor Mahesh Chavira, can you also please come here? Right. So on behalf of Professor Chandrajith, basically I will ask Dr. Pasan Bandara to receive that token of appreciation, which he will arrange to send it to Professor Chandrajith. Right. Mahesh. Thank you. Let me now invite
Okay, thank you from my side.
Marathunga to give the token of appreciation to Dr. Sajith Edirisinghe. Mahesh, you can be here as well. Now to deliver the vote of thanks, I will invite Dr. Pasan Bandara, Secretary to Committee on IDTDS.
Okay, good evening everyone. So again, we had another successful seminar on an exciting hot topic of these days, and celebrating the Earth Day 2024. We had very nice speakers. One of them, Professor Rohana Chandrajith, joining online from Peradeniya, and then Dr. Sajith Edirisinghe, who came all the way here to have this seminar with us. So I would like to thank our resource person. Thank you for sharing your wisdom with us. Thank you for shining a light on something that is really concerning and something that requires knowledge from various disciplines at once to solve this problem to a certain consistent manner. As you can see that we are still identifying some of these problems. We don't even know the scale of some of the problems. Like for example, we say this large term microplastics, maybe nanoplastics, but sometimes we may have to identify what type of microplastics, what type of materials are there, and then probably we have to think where these things came from. For example, there was like one study recently published about the plastics in water, drinking water. So definitely some of the materials came from the material of construction itself, and then they had signals that microplastics coming from the filters that we use to treat water, which is alarming because we think when we filter water, it's safe to drink. But apparently some of the nanofibers, microfibers, they come from the filters as well. So it's a wicked problem, and we in this seminar series talk about a lot of those wicked problems, and then we're shining light on those things, and we hope that various researchers from wide range of disciplines will get together and work on these things in future to find solutions, find sustainable solutions for those things. So it's another successful event. We had plenty of participants from the online as well. So I would like to thank our resource persons again. Thank you for accepting our invitation, coming here and sharing your time with us. We would like to thank Professor Mahesh Jayawira for his generous contribution, and appreciating our speakers is one of the major things, and thank you for contributing to that. I'd like to thank SLAAS General President. Thank you, Madam. Your presence is really helpful, and you always encourage us to keep working on these type of activities. This activity, in fact, was organized in collaboration with the Environment Committee. So I would like to thank our representatives from the SLAAS Environment Committee as well, Professor Manuja Lama Balsuria and Dr. Ureshani Kanaratna, for helping us with coordinating with the speakers and the other arrangements. So thank you very much to them as well. I also like to thank our chairperson, Professor Meda, for encouraging us and for guiding us to organize these things. And in a plan to have these kind of activities every month, we will have another activity next May as well, next month as well. So there we'll be talking about, we are celebrating another UN Day, which is the World Migratory Bird Day. And we will talk about very nice aspects in the line of how these migratory birds will affect ecotourism. So we are again trying to discuss about some disciplines that you may not even think how they are even connected. So we will have such interesting talks during this year. We will promise to bring you those things in a hybrid manner. And the technical support that is given by the Technomedia is enormous, and they are helping us to go beyond these walls of SLAAS headquarters and reach other people who are interested in these discussions. So then I would like to thank Dr. Ruan Kalubovila and his group for their technical support and helping us. And also I have to thank the people from the SLAAS head office, Kasun, and other members who are helping us with the technical matters as well as refreshment. So thank you very much, and thank you for tuning in today. We will come again, we will meet you again with another exciting seminar like this. Thank you very much.